Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom model for yolov5 on Windows 11. Okay, but before we move to a practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, for that, first we are going to do all these things step by step. Okay, so we need here Tony Python ID. So tony.org, this is what their official website. Then go to the window, click on here, it will download our setup.exe file. Okay, so I have already downloaded setup.exe file, and also I have already installed Tony on our Windows 11. So as we always install any normal software on our Windows, simply click on next and it will install Tony Python ID on our Windows machine. Then we need here OpenCV and yolov5, so go here and just click on Tony. It will open our Tony Python ID. Then go to the tools, manage packages, and OpenCV -python. Just hit enter. I have already installed OpenCV and yolov5. Okay, so you need to search here OpenCV -python. It will search for OpenCV -python. Click on here and then just click on install. It will install OpenCV. Okay, then we need here yolov5, so yolov5, and just hit enter. It will search for yolov5. So here it is, whatever yolov5. Click on install button and it will install yolov5 on our Windows 11. So we have done with package installation. Now we are going to capture our images for training. So we are going to capture our images with the help of our USB web camera. Basically we are going to create the model which basically detect Arduino board and Raspberry Pi Pico board. So I have created here a repository, the repository which basically we are going to use for capturing image. Also we have here our Google Colab file for training purpose. Okay, so img.py, and this is what our Google Colab file. So I will mention the link inside description box. Copy and paste link inside the browser. Then go to the code. We are going to download zip format folder. Okay, so as you can see, it's downloading our file. So go here, show in folder. Then this is what our folder in zip format. Right click, extract all. Click on extract. This is what our folder. Double click and img. This is the Python file which we are going to use for capturing our images. Okay, so we are going to open this file inside our Tony. So just close all these things, minimize the browser, and again we are going to open our Tony Python ID. So go file, open, and we have our folder inside downloads, and this is what our folder. Okay, again same folder and img. This is what our Python file. So as you can see, this is what our Python file. As I mentioned, with the help of this file we are going to capture our data images, or we can say our object images. So 30 is basically max frames. It means right now I am going to capture 30 images for each object, for Arduino and for Raspberry Pi Pico board. Okay, 30 images. If you want to change the number, if you want to increase the frames, simply change 30 with 70. If you want to go 100, simply mention here 100. Okay, it will capture 100 images of each object. So right now we are going to capture here 30 images for each object. So just save it. Now here cv2.imret, here we need to mention the path here. Okay, from images. Okay, so this is what the path. So right now we are going to save our images inside download folder, our same repository folder, yolov5 win11 custom obj -main. This is what our folder, this is the folder, this is zip folder, and this is what our main folder. Okay, so inside that we have again a folder same. So here we are going to create our images folder, and inside that images folder we are going to save our all data. So right click and then new folder and images. That's it, images folder. So just click here, and this is what the path. Okay, so right click, copy, and we are going to paste the path here. We need to paste the path here. Just images. Okay, so from images we are going to remove all these things, and we are going to paste our new folder path, Ctrl+V. Okay, and now what we are going to do, we are going to change this slash, this backward slash with forward slash. Just change the backward slash with forward slash. And this one also. Okay. And then our folder is basically inside this folder. This is what our folder, and inside this folder YOLO5 Win11 custom obj -main, this is what our folder, and inside that we create a images folder. So here we need to mention our images folder. Okay, so this is the way you need to mention the folder path where you want to save our all images. Okay, so now what we are going to do, I have already mentioned here Arduino. So this is what our first object, the object images. Okay, so you need to mention here your object name. So right now we are going to capture Arduino board image. So simply I have mentioned here Arduino. Then after we are going to mention here pypico. So let's just capture 30 images of our Arduino board. So now I am going to save the code and I am going to run the code, and then I am going to show Arduino board in front of our USB web camera, and we are going to simply move our Arduino board slowly to front of camera, and it will capture 30 images of our Arduino board. Okay, so let's just start code. As you can see, this is what our Arduino Uno board, and I am moving Arduino Uno in front of camera slowly in different angle. It will capture images of our Arduino board. So we have successfully captured 30 images. So let's just cross check inside downloads. We have here YOLO5 Win11 custom obj -main. This is what our folder. So just click again same folder, and inside that we have images folder, and as you can see inside folder images folder we capture all our 30 images. So if I open like this way, this is what our board images. Okay, so same way now we are going to capture pypico board images. So here we want to simply change the Arduino with pypico. So just remove Arduino and -pico. Let's p capital make. Okay, pypico. So just save it, and again we are going to run our code, and this time we are going to show our pypico board to our web camera. So save the code and run the code. And as you can see, this is what our pypico. Same way we need to move our board in front of the camera in different angle slowly. Okay, so we have captured our all 2 object images. So if I again open download folder, images, so now we have our pypico images also. As you can see, pypico. Okay, so we have done with our data capturing process. We have our data ready. Now what we want to do, we need here labelimg software. Okay, so friends, one more thing I just want to mention here, labelimg is not work with Python 3.10 because I have already tried it, it's not work, there is an error. So we need here Python 3.9. So before we install labelimg, we need to install Python 3.9 on our Windows machine. So just open Microsoft Store. Here we are going to search for Python and then Python 3.9. Click on Python 3.9 and just install Python 3.9 on Windows machine. I have already installed Python 3.9. Simple. Now we are going to open again our Thony Python ID, and here what we want to do, we want to change the interpreter. So right now we are in Python 3.10. okay, so let me show you. I am going to close all these things, and again if I open Thony, and as you can see by default it's work with Python 3.10, but we want here our labelimg software, so we install Python 3.9. so we need here Python 3.9 inside our Thony. So for that we need to go here, run, configure interpreter. As you can see, configure interpreter. Inside the run we have first option, select it, and here we are going to select our Python 3.9, this one, as you can see, Python 3.9, select it, click on OK, and now we have Python 3.9 inside our Thony. Okay, so this is the way you need to change the environment. Simple. Now go to the tools and open system shell. So now here we are going to install pyqt5 and our labelimg. So run the command pip install pyqt5 and just hit enter. It will install pyqt5. I have already installed. Requirement is already satisfied. Then pip space install labelimg. Pip install labelimg. It will install labelimg. So I have already installed both packages. Okay, so requirement is already satisfied. So this is how you need to install pyqt5 and the labelimg. Now we have our labelimg. Simply we need to run the command labelimg. As you can see, labelimg, not emg, basically labelimg. So just hit enter. As you can see, we have successfully installed labelimg, and now we have our labelimg. Now go to the open dir, and we are going to select our dir where we have our all images. So downloads, then yolov5 win11 custom folder, obj-main, same folder, images folder, select folder. Now we have our images. Again we are going to change the save dir, same dir. Okay, downloads folder, again same folder, images folder, select folder. That's it. Now here we need to select YOLO, create rectangle box, and we are going to simply draw a rectangle on our Arduino board, and here we need to mention Arduino. This is what our class name, Arduino. Okay, click on OK. Simple. Same way, just save the image, next image, create rectangle box. Again we are going to draw a rectangle here, same label, same image, just click on OK. Save it, next image, rectangle box, draw it on our board, click on OK. So this is how we need to draw a rectangle box on our object. So now I am going to draw a rectangle on our Arduino board, then we are going to draw a rectangle on our RPiPico. Okay, so friends, we are done with Arduino board. Now we have our Pico board. So again create rectangle box, and we are going to draw a rectangle on our RPiPico, and we are going to mention here RPi-Pico. Okay, RPi-Pico, our next class. Click on OK, save the image, next image, create rectangle box, and just draw the rectangle box on our RPiPico. Click on OK, save it. Okay, the next image, create rectangle box, and just draw a rectangle box like here. Okay, so now same way I am going to draw a rectangle box on our Pico board. Okay friends, so friends, we have successfully draw a rectangle on our last image, which is our RPiPico. So we have done. Now simply close the labelimg software, close the shell, and here we need to change the Python version. Okay, again, so go run, configure interpreter, then here we need to select first one, which is by default Python 3.10. Select it, click on OK, and it will automatically change our Python version. So now we are in Python 3.10 version. Simple. Now what we are going to do, we are going to create a folder. So again we need to go inside downloads. This is what our repository, which we clone or which we basically download as a zip format file. So yolov5 win11 custom obj-main, this is what our folder. Again same folder, and we have our images folder, and inside that, as you can see, we have our files and images. Okay, so now what we are going to do, we are going to create a data folder. So for that, what we want to do, we want to go back, okay, a yolov5 win11 custom obj-main, where we have our images folder. So here we are going to create a new folder. So right click, new folder, and mention same name as I mentioned, data folder. Again click on data folder. Now we are inside the data folder. Now here we need to create images and labels folder. So right click, create images folder, and second one is our labels folder. So labels. So we create a two folder, images and labels, inside data folder. Now again go inside images folder, and here we are going to create training and validation folder. So training, so right click, new folder, training, and next one is our validation. Okay, so we create data folder, inside that we create images folder, and inside images we create validation and training folder. Now again go to the data folder, then labels, and here also we are going to create training and validation folder. So just right click, new, training folder and validation folder, validation. Okay, so data folder we create two folder, labels and images, and again inside images we create validation and training folder. Okay, and same way we create inside labels, we create validation and training folder. Now what we are going to do, go here, yolov5 in our main folder, and we have here images folder. Just copy all the data, so press Ctrl+A and just copy it, copy, and we are going to paste all these things inside data, images, validation, just paste it. Okay, then same way in training, just paste all the things. Now again go to the data, inside labels, validation, paste all the things. Again go back, labels, inside training, paste all the things. So this is how you need to copy and paste all the data from images to our data folder, to images, training, copy and paste, then validation, just paste. Same way inside labels, we have training and validation, just paste the data. Here also just paste. That's it. So we have successfully copy and paste all the data inside our data, labels, images and training validation folder, both folders. Simple. Now what we are going to do, we need to create the zip file. Okay, so just come here, our main folder, and this is what our data folder. So we need to create a data.zip file. So right click, because I have already installed here WinRAR, so just add to archive, click on zip, data.zip, just click on OK. It will create our data.zip file. As you can see, this is what our zip file. Now we need to move this zip file on our Google Drive. So friends, I have opened my Google Drive. So right click and click on file upload, and then we are going to go inside downloads, our yolov5 folder. Then we have here our data.zip file. So just select, click on open. It will upload our data.zip file on our Google Drive. So now open Google Colab. As you can see, this is what our Google Colab. Go to the file, click on upload notebook, choose file, and we have our folder which is yolov5 in 11 custom obj. Select it, again same folder, and this is what our, as I mentioned, this is what our Google Colab file. So just select, click on open. It will upload our file on our Google Colab. So as you can see, it's uploading. So friends, we have successfully upload our file. So go runtime type, change runtime type, select here GPU, save and click on connect. So friends, as you can see, connected, we successfully connect. Now we are going to run our code step by step. So this is what our first code, just click here. It will install yolov5 on our Google Colab. Done, just scroll down. Now we are going to connect with our Google Drive. So run our second code. So permit this notebook to access your Google Drive file. So click on connect to Google Drive. Select your Gmail ID. Scroll down, click on allow. Now it will mount our Google Drive on our Google Colab. So friends, we have done, and as you can see, this is what our data.zip. Now we need to unzip our data.zip. So just run our next code. It will unzip our data. And as you can see, we have our images, rpy pico and their text file. we have our Arduino image and Arduino image. Also we have Arduino text file. Now what we are going to do, we need to click here, which is the folder icon, and then YOLO5 train, then YOLO5, and here we have dataset YAML file. So just double click and it will open our dataset YAML like this way. Here we need to mention our own class. So our first class is basically Arduino, which I have already mentioned, but our second class is RPyPico. So just remove this ESP32 and we are going to mention here RPyPico in single quote, RPy hyphen capital P and Pico. Arduino RPyPico. This is what our two classes, this, or we can say this is what our two object. And here the number of classes same, because we have here two number of classes. If you have 4, you need to mention here 4, and your 4 classes names you need to mention this way: first, second, third and 4. Okay, so right now we have only 2 classes, so 2, and I have mentioned 2 names of our classes, Arduino board and RPyPico. Okay, now simply click here and press Ctrl+S. It will save our dataset YAML file. Simple. So just close, and now we are going to run our last code. Just scroll down, and this is what our last code, it will create our model. So click on here. So friends, as you can see, our training is started 0/99. So it will take some time. As soon as our training completed, I will start video again. So friends, our training is completed, and as you can see, this is what our classes Arduino and RPyPico. And our model is saved inside runs train exp. So just scroll up and go YOLO5 train, just click here YOLO5, then the runs folder. As you can see, the runs folder, so runs, and inside that we have train folder, exp folder, weights and base.pt. This is what our custom weight file, base.pt. So just click here and just download. Okay, so it's now downloading our base.pt. So friends, as you can see, we have downloaded our model base.pt. Okay, so just click here, show in folder. This is what our model. So just minimize, and what we are going to do, we are going to close all these things, our Google Colab, our Google Drive and all these things. And now again open our file manager. This is what our model. So now what we are going to do, we are going to move this model inside our repository, our folder. So right click, cut, downloads, YOLO5 Win11 custom obj-main. This is what our folder, same folder again, and here we are going to paste our model. So just paste. We have base.pt. Why here? Because we are going to create our Python file in same folder. Okay, so now close all these things, open again Tony, and we are going to create our new file. Click on new. We need to mention the file, so just click on save, and we are going to save our file as I mentioned in same folder. So downloads YOLO5 11 custom obj-main, again same folder, and here we are going to create our new Python file. So test.py, simple name. Click on save. Okay, so first we are going to import CV2, then we are going to import torque, then we need to mention our custom model path where we save our base.pt. So go to the file manager and downloads our main folder, YOLO5 Win11 custom obj-main, again same folder, and here we have our base.pt. We save our model inside YOLO5 Win11 custom obj-main. This is what our repository. So just click here, it will show the path, copy it path, close the manager, file manager, and we are going to mention our path like this way: path is equal to, in single quote, just press Ctrl+V, and again we are going to change this backward slash with forward slash. Forward, here also same way. And then at the end we need to mention our model name, best.pt. Simple. Now after that we need to mention our model. So our model by default model path. As you can see, this is what our by default model path from pytorch.org. This is their website. Okay, so just copy this model path and open Thony and just paste. And here what we are going to do, because we are going to use here our own custom model, so we need to delete this yolov5 s. Okay, so just delete, and here we are going to mention custom, because we are going to use here our own custom model. So custom, simple. And then we need to mention the path variable, because the path variable is our model path. So simply here we are going to mention path, and then we need to delete pre-train is equal to true, and we are going to mention force hyphen reload is equal to true. So force hyphen reload is equal to true. So then while loop, and then first we need to mention here our camera. Okay, so we are going to mention here our camera. So cap is equal to cv2 dot video capture, as we always do, video capture, and inside that we need to mention our index number. So I have here only one camera, so 0 web camera or USB web camera. Okay, then rate frame is equal to cap dot read, okay. So this is what our basic code which basically start our web camera. Okay, so if I save and if I run, and friends, as you can see, it started our camera. So now we need to call our model, then it will detect our object. So our model, so after where we resize our frame, here we are going to mention results is equal to our model, and inside that we need to pass our frame. Also we need to call our numpy, so import numpy as np. Okay, and then here where we call our model, results is equal to model, and inside that we mention our frame. Here we need to mention frame variable, and then we are going to use np.squeeze function. So np.squeeze, okay, np.squeeze, and then inside that we need to pass results.render like this way. Simple. So if I save the code and if I run the code, so friends, as you can see, it started our frame, but let me make a frame cv2 dot, okay, I forget to mention here frame variable. That's why the frame is by default frame. Okay, it's not changed the width and height. So I forget to mention here frame variable. Now it will select our width and height which we mention. Now that's good. Okay, so here if I show Arduino board, and as you can see, it's detected our Arduino board. Okay, let me make like this way. It's detected our Arduino board. Now if I show Pico board, and as you can see, it's detected our RPi Pico also. So we successfully create our own custom model which basically detect our custom objects. So here we have Arduino board, and here we have our RPi Pico. Okay, so I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.